So in this video, we're going to look at how do we solve inequalities involving rational functions where it's not a visual, there's no graph. Now you could certainly graph, but that is extremely time consuming by hand and it's not a realistic strategy. So how do we solve this? So the first thing I want to do is draw attention back to the two places where we can go from positive to negative or negative to positive. And that was zeros of a function and the asymptotes of a function. Now, as I mentioned in the last video, that is not an absolute. We're not for sure going to change at those places. As far as zeros, if you have an even multiplicity, you might have a bounce, it might bounce off. And for asymptotes, once again, if you had an even multiplicity, the two values be on the same side. It could be positive and positive or negative and negative. So it doesn't necessarily change, but we still need to check these. Now, we typically refer to these as critical values. These are the places where it can change. These are the places that we need to be aware of what's going on around them. And so the first thing we're going to do is we're going to find the zeros and find the asymptotes. Now, in finding the zeros of a rational function or anything that makes that top polynomial equal to 0. So we're going to start by saying x minus 3 equals 0. Now, it is squared, and so that tells us about multiplicity, so we'll have to think about that. But x minus 3 is 3, so we have a critical value of x equals 3. Now the bottom piece we said equal to 0 to find the asymptotes. So we have x squared minus 1. I factor that to be x minus 1 times x plus 1, the difference of two squares. And if I set each of those individually equal to 0, I have x minus 1 equals 0, x plus 1 equals 0. So then I have asymptotes at x equals 1 and x equals negative 1. Now these three pieces collectively are going to be my critical values. And the way that we do this is we create a partitioned number line. And what I mean by that is this. We're going to put each of these values up in numerical order on the number line. Those are my three critical values. And we partition this up. We cut this into chunks, as in there's that piece to the left of negative 1. There's a piece between negative 1 and 1, the piece between 1 and 3, and everything to the right of 3. We have partitioned this. We have chunked this. Now we do this because we know that this graph will have positive or negative numbers here or here, positive or negative, if we're looking at this line as the x-axis. And we simply want to know, are the values in these particular regions above the x-axis or below the x-axis? And how do we check that, these different partitions? The way we do that is we pick test points between these particular values or in these particular partitions, and we just see, we plug it in. Now, this sounds like a lot of work, and it sort of is, and at the same time, it's sort of not. I don't actually care what value I get. I simply care, is it positive or negative? And so here's what I mean by that. I am going to pick some test points. And by the way, when you pick test points, always pick nice, easy numbers. There's no bonus points for picking hard numbers. So like between negative 1 and 1, I'm going to pick 0 because 0 is easy to do. I'm going to throw out a negative 2, I'm going to throw out a positive 2, and I'll throw out a positive 4. These are values in those particular partitions that I'm going to plug into the function there just to see, is it giving me a positive value or a negative value? And here's what I mean by that. So if I plug in negative 2, so I plug in negative 2, and I have negative 2 minus 3, that's negative 5, but negative 5 squared is going to be a positive value. I plug in negative 2 squared, well that makes it negative 2 times negative 2 when I plug it in right there is 4. 4 minus 1 is positive. I have a positive value over a positive value. That means that for this region, I have positive values. All right, next, I plug in 0. 0 minus 3 is negative 3, and negative 3 squared is positive. I plug in 0, and I have 0 squared is 0 minus 1. That's negative. So this collectively gives me a negative value. All right, I go to plug in 2. 2 minus 3 is -1, but -1 squared is +1, so that's going to be a positive value. And then x squared minus 1, so that's 2 squared is 4. 4 minus 1 is positive. So this region has positive values. All right, and then I go to plug in 4. So 4 minus 3 is 1. 1 squared is +1, so that's positive. And then 4 squared is 16 minus 1, that's also positive. And that is positive. So when I look at these values, these partitions, look at values in there, I got a positive over a positive, which leads me to a positive value for that region. I have a positive over a negative, which leads me to a negative value for that region. Positive over positive leads me to a positive, and positive over positive leads me to a positive. This question, this inequality said, when is this function less than or equal to 0? So important things to note here. I'm only interested in the negative values when it is less than or equal to 0. So for what values is this less than 0? Is it negative? And the only place it is from -1 to 1. So my solution is -1, 1. Now the question is it brackets or parentheses? And here's the thing. When you pay attention to these details, you have to pay attention to, are we talking about asymptotes or are we talking about zeros? Because this says less than or equal to, less than or equal to. So it can be equal to 0. So if we're looking at a value that is a 0 of the function, it could be included. However, if the values we're looking at are bound by asymptotes, asymptotes aren't, those aren't values. Those don't have an output. So it can't be, so when we look at this, oops, let's pick the green color. -1 was an asymptote, a vertical asymptote. +1 was a vertical asymptote. 3 was a 0. 3 was a 0. So when I look at the region that is bounded by -1 to 1, it is bound by asymptotes, which means that the value -1, this does not equal 0. When I look at the value bounded at +1, it's an asymptote. It is not a 0. It cannot equal 0, which means these have to be parentheses. These have to be parentheses to be there. Now, this might change. This might change if this had said greater than or equal to. If it said greater than or equal to, we will need to pay attention to some of those details. Like this is in fact 0, and that might change things. We also have to pay attention to what if it doesn't have equal to, it's just less than or greater than. That changes things. It may include zeros or it may not include zeros. So you have to pay attention to, is it greater than or equal to, or just greater than, less than or equal to, or just less than. All of those things factor into, am I actually including the endpoints of the region that has the value that we're looking for? Is it asymptotes? Are they zeros? Is it include zeros? Does it not include zeros? There's a lot of different ways these can work out. So pay attention to those important details.